Howdy everybody in YouTube land. If you remember from our previous video, we recapped the monitor, we cleaned out the controls and did all the usual stuff that, that's so common on these older ones, but we still have the vertical insufficient height fault, plus some weird color artifacting. I'm not sure why that, I've never seen that on a CRT. Anyways, so first thing we got to do when we're troubleshooting a monitor with no schematic, and the schematic to this monitor is probably not available. It might be, but I don't know. First thing we want to do is we need to study the vertical circuit. So this chassis uses an LA7830 vertical output IC. So let's take a look at this IC and figure out what we got going on here. So let's see. We know this uses 30 or 24 volts to 30 volts as the VCC source. So, there we go. Pump up output power supply. So it's got 20 for the example circuit. We got 24 volts coming in. Well, let's start there. Since we have this, let's start with the vertical output stage and see if we have proper voltage getting to that IC, because if the voltage is low, there's the problem. So let's check that out and see what we get. So let me flip this up, which I need both hands to do that. Alright, now I got this guy flipped up, we have, let's see what voltage it's on. Pin 6, which is going to be right here. So let's follow that. That goes to, let's see, 6, goes to this jumper right here, which is hitting into this circuit, which is a lot of different, well, that's ground. That doesn't make sense. 3, 4, 5, 6. Pin 6 is going to ground. That doesn't make sense. That is, wow, interesting. Hold on. Power supply, 1, 2, 3, pin 3. Where's pin 3 go? 1, 2, 3. There goes to that diode, which goes to this capacitor, and we replaced that capacitor. So, alright, and we also replaced that one. Oh, never mind. It's not going to ground. I'm looking at it wrong. Yeah, well, no. That's 7. That's pin 6. Yeah. Okay. That makes sense now. 6. Down, around town. Going here as well as over here. Jumpers to that. Ah, there's that same diode again. Off the filament supply. Because remember, we just chased the filament supply in the last video, but we're going through this diode. This diode, there's a capacitor here, which I didn't replace. And it goes across this jumper and around to this diode, as well as this cap, which we did replace. So, alright, how about we start checking some voltages? And how we're going to do that is we need to find a good ground point for my probe here. Let's see, where do I want to make ground? I'll just, well, no, that's not really ground. Well, actually it is, so let's steal that ground. I'll just probe it up there. Alright, so let's turn the monitor on. And let's check voltage right here. That's the correct voltage. So we have the proper voltage coming in. Let's check the deflection output voltage. Yeah, that's normal. So we have valid. Alright, so turn that off. We have proper B plus going into the vertical output IC. So, okay, let's see, output yoke. Let's see, pin 2. Pin 2 is vertical output. So let's follow 2. See, 2 goes to that resistor to something else, but it also goes around to that resistor there, which then goes all the way around to that capacitor that we replaced, Alright, so we need to find the vertical yoke, which is over here. That's vertical. Now, let's see, it's going to that cap there, which was replaced. Not sure where M goes. Well, let's see. Let me think for a minute. That's horizontal, so that's got to be vertical yoke. Because it's going to that capacitor there, but then the other one, where's the other one going? The other one goes down, around, goes to this jumper, which goes up to that jumper, which comes up and around that jumper, which goes right there. So there we go. So if we follow that, that jumper goes down to J36, which comes over to J38, which comes back down to J30, which goes all the way up and around to the yoke. Okay. Alright, so it's entirely possible, too, that the vertical output IC is bad. Not impossible. So I'm thinking, where's the drive input? So pin 4 is input. So it's literally going to be a drive signal coming out into pin 4. So if we follow pin 4, 1, 2, 3, 4. 4 goes to this capacitor here, which is not used, but it also comes up. 4 goes to that resistor, but it also goes to another capacitor. Let's see, resistor. Let's follow that resistor up. I can't see it now because now that there's no light. So we got 4. Let's see, pin 4, which comes around. See, 1, 2, 3, 4 comes around. Okay, so here I gotta follow it right. So 4 goes to that resistor, which comes across, which is going to, okay, it's going to this IC right here. So literally, we have that is generating the horizontal and vertical drive. Pretty sure. What IC is that? Let's see. Let's look that one up. Alright, that IC is HA11235. So let's look that one up. HA11235. Let's see, HA11235. So HA11235. Let's see, semiconductor. Let's see, what is this one? And this is how you troubleshoot monitors without a schematic. You got to look up. Let's see, synchronous signal processing system. What does that even mean? Horizontal automatic frequency control, horizontal oscillator, and vertical drive. So this chip is doing the whole thing. So, yeah, that's legible. So this is doing both horizontal and vertical. And we got horizontal, so vertical oscillator and driver. So I wonder if there are waveforms in this thing. Because what would be nice is if there's a waveform chart. Nope. Of course not. Why would there be? Wouldn't be my life if I didn't have the right. Yeah, so that's just not readable. Oh well. Alright, well. So we got proper voltage coming into the IC. The next thing I got to do is I need to see if I have the correct drive signal coming from this, which should just be a pulse, a square wave pulse. If that looks good, then we have a bad vertical output IC. That's just all there is to it. I will go through here and check the diodes and make sure there isn't anything going on there, but I'm leaning more and more to that IC being defective. And it wouldn't be the first time I've seen that. I've worked on TVs where that's just happened before. So, all right, let's check all that out. Okay, so now I got my oscilloscope out, so we can actually do a check of the drive waveforms and all that stuff. I spent the last couple hours searching the internet high and low for the schematic on this monitor, and it's just not available. There was a repair FAQ that was made God knows how many years ago that shows a company that possibly sold the schematics to these, but turns out the owner of that company sold it off and retired in 2017, so that's the end of that. I can't find it anywhere. The only thing I can find is a schematic to the power supply, which does me no good whatsoever. There are some repair notes on this particular model. There's been different revisions of this model made by different manufacturers. So there's some notes in there that claim there's a problem with the TDA vertical output ICs, but this doesn't use a TDA. This is a newer model, so it doesn't have that. Unfortunately, that's not applicable to this one. So we're on our own. I don't know what different models of monitors or TVs out there that use the vertical output circuit that's in this, but right now I'm literally flying blind. So at this point, what I want to do is check the signals going into the monitor. One thing I noticed right away is I can crank up this brightness, this vertical height control. I can crank it all the way up, bottom it out, and I actually can get more height out of the picture. Unfortunately, there's pincushion distortion. So it alleviates the blue shading issues I was having when I turned the height up. But it's supposed to fill the screen. So unfortunately, we're not getting that. So there's still a problem here. I'm not getting sufficient height. This roster is supposed to go into the overscan area according to the service manual. And I found the service manual of this monitor, but in typical IBM fashion, it says insufficient vertical height, replace board. Thanks, guys. Anyway, so let's get this flipped over, and we're going to start probing some drive signals and see if we can't see any smoking gun here. I wish I had a decent tripod so I can actually set this up properly, but I do not, so we're going to have to do this by hand. Alright, let's start checking drive signals here. This is, I think it's this pin here. Yeah, I'm not sure quite yet. I gotta, let's see, let's turn my probe. Let's do an on, hold on. I gotta figure out which way this goes. Nope, that doesn't go that way. So, yeah, that's right. It goes right here. Pin 4. Pin 4. Alright. I need to do an auto. See if I can do an auto setup here. No, it does not. It's just barely, I barely got a signal coming out. So let's check the drive signal going to the yoke. So yeah, let's check the yoke here. Pin 2. Oh yeah, there you go. Let's auto set that. Yeah, that doesn't look good. 2 volts AC. Let's check this. Let's change this to DC. Turn the voltage up. Let's see. There we go. Well, AC. All right. That's not terrible. No, that's about what I would expect. But the amplitude's a little low. 10 volts AC. See, peak to peak's 34 volts. 45 hertz. It's a little low. Isn't it supposed to be around 60? The oscillator is in a free running state right now. That spike is a little odd. I don't remember that spike being in the vertical circuit on most TVs and monitors, but that waveform is normal. So, but based on what I saw on the screen, it looked normal. It's just it's insufficient height. So let's take a look at this vertical size control signal and see if that has anything to do with anything. A little bit, not really. Yeah, there's the sawtooth. It's about what I expect. So, I'm probing that one right here. It's a sawtooth. That's about what I expect. That's the vertical oscillator. That changes the amplitude of it. Let's check the next one over. That doesn't do anything. Let's check the wiper. Kind of low. So we've got a vertical sawtooth coming in right here, which is going to M. M is a wire. Yeah, M is a wire. So that comes out to this guy right here, which is right off of that capacitor. This is on the other side of the yoke. So it comes on this side of the capacitor. Okay. And on that side of the capacitor. Yeah. I'm checking that cap. So this cap goes up to M, which comes to this point, which goes into the vertical size control. So the size is connected into the feedback loop of the yoke, and this capacitor was replaced, so I know it's not bad. And this is going to be a low ESR cap because it's a high frequency switching. This is that big tall Daewoo cap that was there, the big orange one. So, and remember, we saw a large concentration of glue here. Turn the power off. We saw a large concentration of glue in that section in the earlier video. I cleared all that out, but I wonder if, because you saw the corrosion, that old circuit glue goes conductive. So I'm curious, I'm starting to form a theory here that circuit glue was causing shorts that might have taken out something on this board. So, because I have the correct drive signal, but the amplitude's too low. And the reason why is that vertical output IC, you have a B plus input, which is coming through here on this input there, but there's a diode there. And the reason why there's a charge pump built into this IC. It's designed on purpose to step the voltage up that drives the yoke. So that voltage should be significantly higher than what it is. So we're only getting, you saw, we were only getting about 30, 40 volts peak to peak on the drive output waveform going to the yoke. That's not high enough. So there's clearly a fault in this circuit, obviously. So we need to find out where that fault is. And it's interesting enough that the circuit glue surrounding that capacitor, this capacitor is part of the vertical circuit. So I am starting to have my suspicions that we have, yeah, see, there it is. Ah, see? There's a jumper link here. And remember, it was corroded. This is the output. If you follow that, it goes up and around to the yoke. and it had glue that was shorting it next to these other ones, and this is ground. So it was literally shorting the output into ground. So I'm beginning to wonder if it just didn't hurt the output transistor in this IC. So it's not able to build enough gain to drive the yoke. That's something interesting. Because here's the thing. The yoke's not shorted, because if the yoke was shorted, it would draw a lot of current from over here, which would pull the voltage down, which it kind of is pulled down, but the heatsink would get really hot because it's drawing so much current out of that IC, but it's not. It's literally cold to the touch. So I mean, I can't rule out a shorted yoke, but I can make a reasonable assumption that the yoke is not bad. And if it is, I've got another CRT with the yoke on it, so I'm not worried about that. But that vertical output IC is looking more and more sussy. It really is. So I'm going to inspect this a little bit further, and I'm going to check a couple of these transistors and this resistor, and I want to see if there's anything that's going to stand out to me as far as the resistor and stuff's concerned. So at this point, I think we need to pull the board, because there's no serious faults, but there's a lack of gain on the vertical output IC. So I need to pull the board again, and we need to do some more spot checks on resistors and other stuff in the nearby affected areas of that vertical circuit. So I think that's what we should do next. Alright, so I got the board back out of here now, and I'm in here spot checking some resistors, especially in the vertical output circuit here, and all of those in this immediate vicinity is good. But then remember how I was saying about the circuit glue that was around this capacitor and where the old one had leaked a little bit. I cleaned it up the best I could, but you can still see some corrosion, right? Especially over here where the glue was. So I decided to, out of, suspecting here, to check these resistors, and that one over there is a 470 ohm. It's good. But then you get over here to R420, which appears to be a 3.9 ohm. I think that is. Or 0.39. I don't know. It's 3.9 ohms. I have to look the color codes up. I'm going based on memory. But the problem here is, if I test this 3.9 ohm resistor, if I can get in here with the why do these leads have to be 7 feet thick? I don't know. I mean, these meters are not... What if you were handicapped and you only had one hand? I'd have to sue Fluke. And seriously, that's 17 ohms. That doesn't seem right. Or no, yeah, 17 ohms. That seems a little high to me. That is not a 17 ohm resistor. It should be a 3.9 ohm resistor. So that right there is a problem, for one. The one below it, I can't really tell what it is because it's all covered in that glue. Yeah, so I'm going to keep spot checking these resistors, but that right there is already a problem. So, and the one next to it, I'm reading 17 mega ohms. So I'm going to pull them both out, and I'm going to check them out of circuit. But if we look at the big 3.9 ohm resistor next to that cap, if we follow that, R420, look where it goes. This is that M wire that goes to vertical size, and it comes across here to ground. So I can only imagine if that resistor is high in value, we're going to have a problem there. And plus, it's coming off the yoke. So that is part of the vertical circuit. That one resistor is part of the vertical circuit. So if there's an issue there, we're going to have issues. So let me remove that and check that out of circuit. So I got the two resistors out of the circuit now. And now that I got this one out, we can clearly see what it is. It's 150k ohm. Let's see how it checks right quick. So I got to do this while holding the phone at the same time because I can't do this single-handedly, at least not very easily. So I think, yeah, that one's fine. I'm going to replace it anyways because of the corrosion, but This one, now that I have it out of circuit, let's measure it. This is supposed to be a 3.9 ohm resistor. I'm pretty sure. I'll have to pull out the service manual. Or not service, but the color code. Shit, I can't even think right now. Yeah, 19 ohms. That's not good. That's bad. I'm pretty sure that's a that is a 3.9 ohm resistor, but that's in the yoke circuit. So if that's defective, then we're going to have issues. So that's probably why we have insufficient height. So I already went and ordered a new IC for this just to have it on hand. Same thing with this one. I went ahead and ordered these two just to have them in case there's a problem. But that is definitely a problem. So that resistor has gone high in value. So I will have to, this, I don't know what size this is. This looks like a 2-watt metal film. A 1-watt or a 2-watt metal film. So that's probably what I'm going to do. This is a 1/4-watt metal film. So I'll get these ordered up. And we'll get them replaced and see what happens. I'm going to spot check some more, but I'm pretty sure that's going to be it. So I will double check the rest of them, but I'm pretty sure that's going to be it. So anyways, I have to wait for parts again, so, and I got to get the right caps for these 3 here because they're still original. I now have the vertical output ICs in hand, and they sell them in packs of 10, and I'll probably have these until the day I die. I likely will never use them all. I ordered them anyways just in case I need one, but I don't think I'm going to need that. And also the capacitors are in here now. The correct 25 volt 330 microfarad low ESR one that I need. We have that now finally. Then we also have the 47 microfarad 25 volt bipolar cap, the ones that Mauser made a mistake on. They sent me the correct ones and they verified it and shipped it to me FedEx. So that's here now. I have that. And then I have a couple of different resistors here. So I didn't know which wattage it was. It's very kind of hard to tell. So I got 2 different ones. I got a 3-watt and I got a 2-watt. So that's what 3 watts look like, and they're kind of big. But I also have the 2-watt, which that might be correct. I'll see. I could look at the reference design of this IC and double check, but I think, well, let's see. Yeah, this is the original, so do we match up with that one? Do we match up with that one? Well, it's like we're kind of in between. But I'm wondering if these are it, so I'll try those. I also have the 150k ohm, which are kind of big. I don't know why they're kind of big. Oh, that's why. 1%. I could have used a 5% here. Oh well, good enough. And I'm only replacing this one out of precaution anyways because of the glue that's all over it. So, alright, well, let's go ahead and let's start getting these parts put back in the board and we'll try it again. I think that's going to do it. I got the 3 new capacitors in place there and I got the old ones out now, so we're good there. Even though those were fine, I went ahead and replaced them. I got the resistor installed. This one is kind of big. And then I have that one installed now. So I'm hoping, and then, I had to change this one too. So I'm hoping that everything's good. So I got to put the monitor back together and try again. But I did not put in the vertical output IC because I don't think I need that. So I bought them anyways, just in case that's what was at fault. But I don't think I need them. So I'm going to leave that alone. I did order these too, but again, I don't think I need them. But just to have them on hand in case there's a failure, never a bad idea. All right, so let's get the monitor together and we're going to try this again. Hopefully this time it works. All right, in the fear of who the hell knows what's going to happen, I've just kind of tacked this in place now. And here's the mistake I made last time is the DAG ground runs under here and plugs into the back of the CRT neck board right there. I didn't have that plugged in last time and I had that jumper lead, so that makes a lot more sense now. Anyways, I'm verifying I don't have any shorts. I'm not sitting on any metal. Got the power supply plugged in, so let's hope that it works because I don't know. Alright, so, okay, what do we get? No kaboominations. See, do we have a raster? Ha, there we go. That's what I'm looking for, right there. Alright. Now I got fold over, which is not surprising. Let's see, do I have... I gotta adjust the vertical height now that, you know. Alright, let's get back here. Vertical size. Let's see. See if we can correct that fold over. Yeah, we can. So we're good. Let's bring you down. Alright, that's not incredibly bad. Let's fill you out a little because I think it goes off screen a tiny bit. It's supposed to. Alright, that's it. So that is much better than what we had before. Oh yeah. Let's turn it down a little so the camera doesn't blink as bad. Yeah, that's a far better, but yeah, we got bad burn-in for sure. I don't know if it's coming across on camera, but it's like it's right in here. There's a menu bar burnt into it. Almost like this thing ran WordPerfect and it just sat on the WordPerfect screen for years and years and years. Yeah, I got some burning. You can definitely tell here. See this? There's a brighter bar, not this line, but next to it there's like a thick bar right here that's brighter than the rest of it. That's the burn-in line. Yeah. It's the burn-in line. But yeah, it's all good. There's a little bit of magnetic polarization here, but that's good. That's normal because I don't have... Let's see. I don't think I do. Yeah, I don't have the degaussing coil plugged in, so... Stay. That's not plugged in. It normally plugs into that power supply. So that's normal. That's normal until I plug that in. But, yeah, we're good now. So let's... I'm trying to debate... I'm at a crossroads here. Do I replace the CRT? Or do I leave this one alone? UXW Bill was talking to me in the comments section on a previous video that maybe I should just leave the CRT alone because it still tests fairly strong and just run this existing CRT into the ground. Because I have a replacement flyback and I have a replacement CRT. So maybe I'll leave those two together and I'll wear this one out. The amount this is going to get used is very, very minimal anyways. So I don't think I need to worry about it too much. I can probably just leave it alone and use it as is. And then when the CRT gets weak or if I don't like it anymore or whatever, then I'll replace it. Because it's not like the CRTs are growing on trees. You're not going to get more replacement tubes. So if this one still has good emissions, and as we saw in the last video that it does, so we'll leave this one alone and just let it run. But perhaps more importantly, the vertical deflection is fixed. So I did not need the vertical output IC, so I have spares. So really, it was that resistor. That 3.9 ohm resistor was reading 20 ohms. And it showed no signs of external trouble. That resistor was open. Almost open. It was drifted high. Which is strange for a metal film wire wound type resistor. That wasn't wire wound. That was metal film. So a film resistor, that is odd. I've not seen a film resistor do that before. But the proof is in the pudding right here. So that resistor was open. That's all it took. Alright, so I think at this point, I want to get the shield put back on here, and I want to get this thing put together and get the cable reconnected. Which is another problem that we have to figure out too, is the cable retaining ring is broke, and it needs to be 3D printed or replaced. I think I got enough there to hold the cable, but I might just fill it with silicone for now. And to hold it in place the best I possibly can. There's not a whole lot I can do about that. But, yeah, let's get the cable snaked in through here because it plugs in right here. And let's turn the power off. So let's get the cable connected, snake through here, and start getting this thing put back together. And we'll do a picture test and see what it looks like. But that's good news. I like where we're headed now. We got the original fault repaired. One thing I wanted to note, I've been letting it run for a little bit. I wanted to make sure this resistor here that I replaced wasn't get overly hot. Just to rule out that I undersized it because I had an issue. Is it 2 watt or 3 watt? So I put the 2 watt in there, and it's getting warm, but it's not getting hot. So I think we're good with that. Alright, so before I get carried away even further, I want to make sure this cable is good. And the only thing I have on the top of my stack that actually works right now that I can relatively grab and quickly turn something on would be this Mac. So this should be set for 640 by 480, but we're going to double check. Maybe. I don't know if it's going to work. Oh, yeah, there it goes. Hey, that looks good. Looks really good, actually. See what the focus looks like. Oh yeah, it's switching into 32-bit mode with System 7.6 is installed on this machine. I don't know. This is the most appropriate use and cursed use of an IBM monitor ever. Macintosh, because why not? So we'll let all that boot up, and it looks like it looks pretty good. The resolution on these monitors are not great. Focus is decent, so I don't have any problems with that. Yeah, I think we're good. I'm going to let this run for a bit, and once I know it's good, I'm going to put it back together. Because I think this cable, let's see, I want to wiggle the cable a bit and see if it Quarko twinkulates. It doesn't look like it's going to. Here's the other end. This is the end that got smashed. Yeah, it's fine. So we'll just let this one sit for a bit. The only problem with putting this together, I've noticed, is I took this apart 5+ years ago. So yeah, it's a problem. But I have the cable now put into this thing. Again, it's broke, but I got enough pieces there that I think will be all right. The clamp is in place, so it's not going anywhere anyways. I may have to loosen this and slide it around. I don't know yet, but the cable is pretty much permaformed where it used to plug in, so pretty sure that's where it goes. And if not, I can always tweak it. Now I gotta get that in here, but before I can do that, I have to plug that in here first and then put the shield on, because otherwise you can't. Oh, anyways, yeah. Ramp mode. Now I have it somewhat put together. I'm gluing this last piece on while I have a flat surface here where it gets gripped on there, because I'm missing a piece here to hold it in. So I figured I might as well just glue it in place here, let it dry, and that'll allow me to tighten the screw down at least and somewhat hold it in place. I got this side on there pretty good, but that still needs work. Alright, it's now back together for the most part, and this is still a little soft, but I'm waiting it to get, hard. I'm not using this for load bearing. All I'm doing is just using that for stabilization anyways, so I think I'm going to go for broke and just put it all the way back together. But I still have some leftover screws here and some stuff I can't figure out where they go. Like that screw, I'm pretty sure goes in here. So I have these two which go on the bottom, but that leaves these 3 left over, and I'm not sure where they go because all the other ones are all put in everywhere they go. And this, for the life of me, I can't figure out where it would even go. There's no... I don't know where this came from. It's matching metal, sort of. But you can see where the screw used to be, so the only place it would have gone is either here, or it can't go there. No, it can't. That doesn't make sense. It can't go there, and you can see where the screw was. So there's no place for this to go. So the only thing I can think of is it didn't go to this monitor. It had to have, though, because it has a 9 for 89 right in the front. It had to go to this monitor, but the question is, where did it go? Service manual, I looked at the service manual and it doesn't show where that went. And you can see where there was a cross member that would have went there because there's a cutout. I don't know where it went. I do not know. That almost feels like that was in a plastic pin and like it went like in here somewhere. No, that doesn't make sense. Can't go here. No. It literally can't go anywhere. There's no... Well, there's only one place it can go. Circular file. Alright. Whatever. I don't care enough. So I'll just go ahead and put the cover on, and we're going to get something set up and then get this thing powered on and see what she does. One thing I didn't go over because I didn't do a take apart video of this is I now have the 4 screws in at the bottom, and this thing had to go somewhere because there's an extra screw left over here and there's an extra screw left over here. So I don't know where it went. I can't figure it out in the system anywhere. I wonder if it who knows, it could have supported the flyback transformer. Who knows? I don't. One of it is, I'm going to throw it in my screw bin, and if I ever run into it, and then I have this screw too, which I don't know where it goes, and that one. So I just got, anyways, the point of this part is the 2 screws that go in the front, okay, they're these stupid security screws. So you got to have a long shank bit to get in there because it's a very deep hole. So if you don't have a long handled screwdriver or anything like that, you're gonna have problems. So there's the one that I need right here. 3rd one over. So let's pull this out of its hole. Or try to anyways. There we go. Man, really? So tight. Alright, so there's the one that I need. So now I should be able to just drop this screw in there like so. And then screw it in. To make this a lot easier and faster, I'm going to use my drill. Oh, that one's in there now. And the final one here will go in its little cornholio spot. That's it. All together. And it got a little bit of smashified on this corner probably from shipping because I got this thing on eBay years and years ago. And that's what happened here. It all got smashed in. But yeah, I got 3 screws left over and a washer. That washer probably went here with that one. I don't know. But yeah, I don't have the slightest idea where I put it. And I took this apart 5 years ago or more, honestly, because I bought this thing when I was living down here and I moved down here 7 years ago, just about. So yeah, it's fun when your memory fades. I got very little working memory anyways, but anyways. Alright, so that's out of the way. Okay, what was that? 33 microfarad, 35 volt from who knows when? I don't need that anymore anyways. Alright, well, we are complete now. So, I want to do one final test. I want to grab a machine and plug a machine into this and do one more test. And that is going to wrap this video up, I think. So let's go do that. So the absolute hilarity behind this is I actually do not have a functional desktop PC right now, an older one. Well, that's not true. I mean, I got a Pentium 4 compact, but all of my era-appropriate PCs, none of them work. They all need service, and I haven't gotten around to them yet. So it's kind of hilarious, actually. But what I do have, though, is, you know, just got to pull out the trusty old Mac again and just use it, I guess. So that's what we're going to do, is just throw this Mac down here and connect it all up and hope that it works. So I got it all together. I haven't turned the monitor on yet now that I put it all the way together, so I don't even know if it's going to work. So, all right. No booms. So I'll have to see. Hopefully that works. I need my mouse. What did I do with my mouse? Oh boy. Huh. I do not have... Yeah, I need to go locate my mouse, but that's a good sign. Yeah, you know what? I may accidentally bump the convergence out of alignment. Oh yeah, because I kept fooling around with the, because it's very hard to get some of the cables in here. So, it's extremely difficult to maneuver around the neck that has all of the rings on it. So, but I'll let it run for a bit. Meanwhile, I need to go find my mouse. There we go, I've got it now. I had to go look in front of my face. Alright. Plug you in there. Alright. There, I have my mouse. I love this mouse. Optical. I'll never get rid of that mouse. It's like my favorite mouse. Roll my chair over here. Alrighty then. Ugh, this thing's bright. I need to turn it down. There we go. Barely, yeah, I'm probably gonna take this thing back apart again because I gotta fix the convergence. But anyway, so, okay, so yeah, we're functional now. Sad thing is, I do not have a functional PC right now. Man, the resolution on this thing is actually not that good, but that's normal. This monitor really was designed to be used with MCGA on the VGA port, but it's somehow actually, yeah, functional. I want to do, actually, I tell you what I want to do. I want to see what the colors look like on this thing, and the only way to do that right now is launch this. So let's move that to the end, set that. Oh yeah, red, green, blue comes out real well. Alright, let's see. Bro, that's dark. Let's turn the brightness all up. Yeah, I kind of see it. Yeah. I might need to do some adjustments too. I gotta get in here and do some adjustments, but rubber band. I think too, this is only a 256 color display. Oh, there we go. Wow. Yeah, that looks really good. That one, yep, that looks good too. All things considered. See, I don't know if this machine will do more than 256 colors. Let's find out. No, it won't. Alright, so yeah, that's not bad at all. Teddy bears. Excellent color reproduction. That's one of my favorite backgrounds right there. Yeah, this thing's got excellent color reproduction. Seems to be stable. Everything's good. Yeah. Some flannel for a good time, right? Flannel. Oh, yes. I remember this. I remember when the first time I saw this, I saw that on an LC 550, I think it was, or a 575 that a teacher had. And back in my classroom in junior high. Oop, pink. Let's see how that looks on the screen. Whew! That's bright. That's a cool one, too. So, yeah, the monitor is working really well. Aw, kitties! You know what? I think I'm going to leave it there because I like kitties. Kitties are cool. I'm going to leave it on kitties. Alright, I need to turn the brightness down because it's blinking pretty hard. There we go. Yeah, this seems to be running pretty well. It's been on for a bit before I put it back together. And when I get my IBM PS2 finished, I may or may not do a video on it. Yeah, I probably will. I'll just pair this monitor with that machine. So everything's good. So let's see. I don't know if I actually have a good program, any good programs on this thing. No, it doesn't look like it. And I do not have... Oh, that's interesting. How did I pull that one off? Because that is supposed to be in here. So is that one. So is that one. And that one. Yeah, that's fine. That's fine. There we go. Somehow. Whatever. Just leave it to me. Anyways. Alright, well, I think that's going to do it. Let's see what text looks like on this thing. About the Mac OS. Desktop printer. You can't really tell, and perhaps everybody knows about it anyway, but there's an Easter egg here. If you look in this icon, if you flip it upside down, it says Dowdy. And here's why. Let's see what text looks like on this thing. Because if I actually go about simple text, Tom Dowdy. So the Easter egg is the developer or the programmer for this software is written upside down in the icon. So that literally says Dowdy upside down above extra. Most people in the vintage Mac world already know this, but if not, now you know. TIL. Alright, well, I think that's going to end it for this video. So we've got it fully restored. It's fully operational. I got some tweaks to the convergence I need to do, but whether I actually do it or not is yet to be determined. It's actually pulling in the longer it runs, so it could be a weak CRT, even though it tested strong. Who knows? Anyways, that's it for now. I'm going to leave it like this. It's all good. So, honestly, at this point, the best way to conclude this video. Let's see if I have it in here. There we go. That's the best way to conclude this video. So, thank you for watching. Feel free to leave a comment if you have one, and don't forget to like and subscribe and all that fun stuff. So, until next time, guys.